Okay, question number 3, part D from May, June 2017, paper 4, variant 1. Transformations continued. This is more about transformation matrices, which I have doubts about whether it will come up because we had some matrices questions, but it's possible. So it's good for us to go through this now, and also for the future years who might watch this video, although I think soon be out of the syllabus because there's 1 year left of it. But anyway, point P has coordinates 4, 1. F and G they represent transformation matrices basically. Find GP, the image of P after the transformation represented by G. So GP means you got to transform this object, which is 1 point, the coordinates of 1 point, by the transformation matrix G. So you're going to write down the matrix G. Always write down the transformation matrix first. Then you write down the point that is being transformed, and you write it down in matrix form, not in coordinate form. Now in matrix form, the x coordinates go on the top and the y coordinates go underneath. And when you transform this object matrix, you have to use matrix multiplication. So I'm going to multiply these matrices together, okay, using row of the first matrix times column of the second matrix. Okay, so that's how you transform matrices. Okay, you multiply them just like the normal matrix multiplication. So you have 1 times 4 plus 0 times 1, well that's 4. And you have 0 times 4 plus 2 times 1, well that's 2. So 4, 2 are the coordinates of the point P after it's been transformed by the transformation matrix G. Now, part 2. Keep that there so we can see what stuff up there. It says find GFP. Now, what this means is it's like functions. Like you remember when you use, if you have, for example, you had functions GF f of x. That means you find what f of x is first, and then you find what g of that is. So the same thing here. You find what f of p is. So it's basically what you're going to do is you're going to transform transform p by the matrix f first. Okay, and the result of that you're going to transform by the matrix G. So the first thing for us to do is to find what P is after it's been transformed by the matrix F. Matrix F is minus 1, 0, 0, 1. Okay, times, and then again P is a 0.41. So that's going to give you, if you multiply, it's going to be a 2 by 2 matrix. Sorry, it's going to be a 2 by 1 matrix, 2 by 1. You have minus 1 times 4 plus 0 times 1, which is minus 4. And you have 0 times 4 times 1 times 1, which is 1. So minus 4, 1, that is the coordinates of P after the transformation matrix, after it's been transformed by F. Then you've got to find what G of FP is. So you've got to take your matrix G, which is 1, 0, 0, 2, and you've got to multiply it by the new coordinates 4, 1. Okay, sorry, negative 4, 1. It's negative 4. Let me write that clearly so you don't. Always write clearly so you don't make copying errors like that. That was negative 4 and 1. Okay, that's negative 4 and 1. So you got minus 1. So 1 times row times column. 1 times minus 4 plus 0 times 1, which is negative 4, and 0 times negative 4, which is 0, plus 2 times 1, which is 2. So this tells you the coordinates of the image after it's been transformed by matrix F. And then where it got transformed by matrix G. Okay, so you end up with the coordinates minus 4 and 2. Okay, one little point to note is that this matrix G is not one of our standard transformation matrices. Okay, this is something that they don't have to give you a standard transformation matrix like rotation or reflection or enlargement or whatever. They don't have to give you such a matrix. Okay, they can give you anything that transforms the object in weird ways. Okay, but what you must realize is how to transform it using a matrix. F is actually one of the standard transformations. Okay, and you kind of can guess what's happened in F. Alright, so like you see, it started off at 4, 1, and it ended up at minus 4, 1. So it started there, and it ended there. You can see it's like reflected in the y-axis, okay? And you can see if we're going to use our method of I and j for f, you start off with I here and you have j there, okay? This is not part of the question, but it's just a side point. If I want to find what this transformation matrix does. I want to describe it. You see, I has gone from 1, 0 to minus 1, 0. That's I dash, and J stayed at 0, 1. So what is the transformation that would cause I to move from there to there, and J to stay where it is? Okay, you have to think about both of them at the same time. Well, that's a reflection in the y-axis. See, reflection in the y-axis, and that's exactly what's happened. Okay, between here and here, it's reflected in the y-axis. Okay, that's what your matrix, between here and here, 4, 1 and minus 4, 1 is reflected in the y-axis. Okay, so that's G f of p. Now, number 3, it says find the matrix Q such that G, Q, P equals P. Well, what does that mean? What that means is the matrix Q has done something to P, and the matrix G has basically undone it. It's done the reverse. Okay, because you end up back at P again. Okay, so QP took it somewhere, and G of QP took it back to where it was. Now, the thing that undoes a transformation matrix is its inverse. So basically, we know that Q is equal to the inverse of matrix G. They're basically telling you to find the inverse of matrix G. Now, matrix G is 1, 0, 0, 2. So the matrix G is 1, 0, 0, 2. So to find the inverse of matrix G, you first got to find its determinant. And the determinant of matrix G is 1 times 2 minus 0, so it's 2. So you're going to have a half times, and then you swap these two around. The leading diagonal swap round, so you have 2, 1. And these two stay where they are. Okay, so you end up with 1, 0, 0, and a half. Okay, that is the inverse of matrix G. And that's what they're asking for. That's Q. So that Q, that's equal to the matrix Q. Q is the inverse of G. 1, 0, 0, and a half. Now, if you wanted to check your answer to make sure that you've got the right answer, you could actually do G times Q. And it should give you what's called the unit matrix. Okay, if you actually multiply these together, that's a half there, you're going to have 1 times 1 plus 0 times 0, which is 1. Then you're going to have 1 times 0 plus 0 times a half, which is 0. You have 0 times 1 plus 2 times 0, which is 0. And you have 0 times 1 plus 2 times a half, or 2 times a half is 1. You end up with the unit matrix. The unit matrix acts like the number 1. It doesn't take you anywhere. So it's basically, when you combine these two together, it's like multiplying the coordinates p by 1. Stays where it is. Okay, so this is the inverse of matrix Q. That's basically this question is just, could have been said, they could have said this, say, find the inverse of matrix G. But they've worded it in such a way to test your understanding of inverse matrices, of transformations and matrices, and such. They're trying to test your understanding of how it links up with transformation matrices. Okay, so it's a very good question, actually. And so there we have part D of this question, which is all about transformation matrices. Okay, so thank you for listening.